I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. We are here in San Francisco learning about edge networking, edge containerization, edge topics. And one of the things that came up is the massive scale of applications that are being deployed. And I don't mean big applications, I mean applications everywhere with all sorts of different interconnects, all sorts of different hardware, everything. And so it occurred to us that we would do a discussion on just that question. How do you deploy applications everywhere at massive scale all around the world? And so here on the panel, we have a group of folks who are participating in the Edge Field Day event. We have both delegates and presenters joining us here. So first, let's meet who's on the panel.
Hi, I'm Simon Gamble. I'm president and co-founder of Mako Networks.
I'm Alastair Cooke. I'm a content creator and analyst.
I'm Carl Moberg. I'm the CTO of Avassa.
And I'm Ben Young, content creator and love all things automation. So looking forward to it.
Great. So let's dive right in. In terms of building massive scale applications and connecting them, I mean, that's what Mako Networks does. So I'm going to start with you. I mean, how big are we talking and why can't this just be done in the cloud?
Well, we build applications and deploy them to customers at massive scale in the form of networks. So we're delivering networks kind of like an application. It's tough because where they're going isn't in the cloud. So we're trying to deploy to lots and lots of small locations. How many? We're talking tens of thousands for some customers, hundreds for others, but a large number nonetheless. Keeping everything ubiquitous, set up appropriately, still leaving some flexibility for movement and control for all the parties involved is important. Without a good solid network foundation, deploying other applications to the edge is impossible. So we create the foundation for applications to be deployed at scale across a large number of locations anywhere in the world.
Yeah, I mean, I think that's key, right? Like without a good networking foundation, with so much reliance on external services, like during your talk, you were mentioning so much about the payment system in the industry and all the other related services that I, quite frankly, wasn't even aware of that was delivered to even a petrol station. Without a good networking base, we can't get applications in and things can't talk back out. So it's all, it starts there.
Yeah, the network's not often spoken about, but if it's not there, nothing else happens. So
except when we're blaming it, right, as application development.
Well, it always gets blamed. Even if the printer stops working, it's normally we're the first people call. But start at the bottom, build the foundation, build the network, deliver that at scale. Then you can deliver applications at scale to those locations, and you can help connect them to other locations. Be that in a cloud, straight into a data center. You were mentioning about a petrol station. A petrol station needs access to all sorts of applications, as an example, that people don't think about. Everything from payments, loyalty, mobile payments, point of sale system support, gift card resolution and processing. Those are all applications, and your devices at a store, at a gas station, have to talk to those application providers somewhere else.
I think I can launch a slogan for the conversation, Stephen, if I may. I'm not going to try to actually find the source of this, but I think it's an architect, which makes it important. I think it said more is different as a general rule. And I think that is super applicable actually to the edge. It is not the same thing as deploying tens of thousands of a access point or of a networking thing. There's an emerging different pattern when you look at that kind of scale. And it really hits across the board. Like, what is an actual healthy network if you run across tens of thousands of locations? Well, there's always going to be tens of locations that are offline for planned or unplanned reasons. So having a KPI that says everything is going well is different from having, a couple of Wi-Fi access points in a location like this. And that also trickles up the stack. And it also provides a very interesting, challenging space to say, okay, there are now a subset of the locations that are misbehaving in terms of the application because we can't reach them. Is that something to worry about? Or is that actually aligned to or connected to something that is planned for already? So, I mean, the big, I think, underlying thing here is that more is different. It's not the same thing as just doing the same thing but 10,000 times. There's an emerging pattern here that is pretty interesting to do or think of or think about, particularly in a panel like this.
So I think there's an interesting aspect to that idea of, in that large population, there's always going to be some failure, and it kind of relates to some of the DevOps thinking around having an error budget, of saying, we expect to have 1.5% of our sites offline at a given time, because that's just how the world works. No matter how good our Mako equipment is, the links behind it maybe are letting us down. So there's some parallels to what we see in the DevOps world in this.
Yep.
And there's a whole heap of parallels about needing all of the automation piece, and especially where you're doing the application deployment out. What we see with these locations is that there are a relatively small number of applications. You might be delivering 6, 10, 12 applications out to each of these remote sites, but you've got to do it exactly the same at thousands of sites. It's a small fixed population, but multiplying through. And so having that solid, consistent network foundation, and then something that's going to help me automate getting a consistent deployment of my applications is going to be absolutely vital to doing this in a way that doesn't have lots of sites down when they shouldn't be.
That's an interesting point. So what you're saying is that there's an SLO, the SLO concept, we have to maybe rethink that, or does it just work out of the box? Can we just start talking about SLOs and failure budgets right away, or do we have to pontificate on the topic for a while?
There's definitely a maturity curve for organizations. I mean, just going into an organization and saying, you're allowed to have some errors in your environment, it's not a problem. That doesn't fly in a lot of places. You've got to design your systems from the beginning with these concepts in play. And the other thing I wanted to circle back on is Stephen introduced that why aren't we just doing this all in the cloud? And that brings back to one of the fundamental elements about edge, is that all of this edge functionality is happening close to where the data is being generated or where the users are. And so, although there's this catalog of things that my Mako environment might connect back to, the important thing about edge is being able to actually run some applications in real time, respond to what's happening right now, right here, without having to send all of that data back over either very slow or very expensive links back to some central cloud processing. And that immediacy and locality of processing is absolutely crucial to what makes edge different as well, and why we have just such a vast number of deployments of the same thing in different places.
Edges are probably getting more advanced too, right? Like a petrol station probably 15, 20 years ago, was vastly different from a petrol station today, and a retail chain. And someone was mentioning today about digital advertising and delivering more things down to these edges. So all of a sudden, the reliance on IT infrastructure at the edge is a lot more than it used to be.
It adds a lot of resiliency as well. So if your broadband connections are down and you're doing edge computing, you're still in business. So I think one of the things that Scale does with their edge computing is delivers resiliency for that processing, in addition to being able to do really intensive processing that the internet links might not accommodate for, and allows retailers or other businesses to be able to deliver experiences to their customers. If we're focusing on retail, retail is a challenging environment. A lot of retail can be done from someone's home, and retailers are wanting to get people into the stores, and edge computing can deliver some pretty amazing features and functions to customers to get people off their couch and into an actual retail location.
That's, I think, the interesting aspect of this too. So I agree with you, what Carl said, that basically more changes everything, and we heard that from Mako as well. I mean, you're saying, if you have 10 locations, you could probably manage it yourself, but if you have 1,000 locations, you definitely can't. And it's the same with everything we're talking about here. The scale just makes it completely not just impractical, but impossible to deliver in a sort of a manual way. Everything has to be automated.
Yeah.
And that's what I'm hearing. I mean, Mako doesn't have 10,000 engineers running this stuff. Avassa doesn't have, 10,000 people manually configuring containers and so on. It's automated. Of course it's automated. That's the only way to do it.
It is.
And by automating it, then it kind of unlocks the next level, which is what you're just talking about, which is sort of deploying more interesting things, more advanced things, more beneficial, hopefully, things at the edge, and collecting more data locally.
Yeah, and I also think when you say delivering things to more locations, it needs to be from a central location. If we had to connect individually to each of these 500 sites or whatever, or fire up VPN connections to talk to automate all of the deployments of the things or upgrade the tooling or whatever it might be, having that centralized panel, and I don't want to use the term single pane of glass, but I did, and I'm doing it. That visibility aspect as well, being able to see exactly what's happening across all of your sites, that's critical. I don't think it wouldn't be viable without that central control plane.
Yeah, agreed. And those sort of control planes allow humans to deal with the exceptions rather than dealing with everything, which allows you to scale.
So, for example, in our product, we debated whether to have an unreachable site as something catastrophic or something that needs to be made actionable, or something to put on some sort of a list. And of course, the debate came down to, do we actually think that the containerized, in this case, applications that people deploy are truly resilient? Because if the majority of them are, we can kind of demote that just to say, whenever you are available to do that, it's inside the budget. It's not a catastrophic, it's not a P0. You can take your time on it. But it turns out, and this ties into another maybe term we can start bandying about, which is edge native. What is that? What in the world does that mean? Particularly for me on the application layer. One of the things that I will offer here as the first edge native litmus test is, does your application crash if it doesn't reach a DNS server, for example? If it does, then you are not edge native. And I'm sure there are other aspects of this that you guys may offer here. But it's been a very interesting conversation, talking to application developers and trying to tell them that these are some of the things that we would like for your applications to survive, that you will always have available if you run in a centralized cloud, but may or not be available at the edge.
Yeah, I couldn't agree more. I mean, I think it comes back to when you're designing the application and designing for those fault scenarios that are most likely going to occur, network outages and things, and even having edge compute there, and it might be processing it, and sure, it might be streaming in real time the processed results up to the cloud, but building in the resiliency within the application that, sure, the network can go down for 10, 15 minutes, an hour. There's enough persistent storage there to hold that process data, and then when the links come back up, start transmitting again, and building that resiliency into the application rather than, oh, I've lost the internet, I can no longer do anything because I can't check the time.
Right. Yeah.
Not a good design, but yeah.
Yeah, I think that's an interesting element as well, is that as we've seen throughout Edge Field Day and the run up to it and our discussions around it, one of the things that is interesting is that we're not talking about radical new technologies. We're talking about using technologies in a different way. And it seems like the keys are things like automation, but also, as you brought up, resilience. So that's another great key, because you cannot assume that every site is functional. You can't assume that every cluster has 3 nodes. You can't assume that you're not running on the backup or the backup of the backup, or that there's not a short outage. And yet you have to make things work. And doing that is a different mindset than it is in the cloud, where you have all the bandwidth. You can have rapid failover, that sort of thing. What are the other characteristics, I guess, that makes it possible to run things at this scale? I mean, we talked about automation as well.
So I can always volunteer another thing, which is there's this relatively recent term, I think our DevOps peeps will like this, called observability. My interpretation of that is when things go south, based on your ability to monitor things, you may want to dive into the specific behavior of a component or a subset of components. Obviously, in a super distributed world with tens of thousands of locations, hopefully you don't have a big switch to tell me, give me the debugging of all these applications at all places at all times, and then hide because of the data flow. You need to have pretty appropriately designed querying mechanisms to say, for this particular component in maybe this location or in this set of locations, give me the debugging in maybe, since 5 minutes and for another 2 minutes, which again is vastly different from single cluster kind of thing, where you can actually afford to turn on, full debugging for a little while and put that into a database and then do post-fact. So the whole observability thing, Amabob, is also something you have to be a little careful about, because it can easily become needle in a haystack and a real data management problem as you try to dive into the behavior of such a distributed or replicated environment. So that's another one that I think needs a little retooling and rethinking.
Yeah, and I think what we see is early on, the management tools tend to be what I refer to as an open loop. They give you lots of information, and the human has to decide what to do with it and how to resolve. And one of the things we dived into with scale computing today was how they build state machines to automatically resolve known issues. And that pattern needs to come more in as a natural progression from observability, where observability is I want to be able to ask a question I never thought I would want to ask of the system, and I want to be able to get an answer to it rapidly so that I can then resolve an issue that I've never seen before.
Yeah.
Well, if I've seen the issue before, I want it to be automatically resolved, which plays back into what's sometimes referred to as site reliability engineering as well. That's a really important part of running the stuff with lots and lots and lots and lots of locations. You don't want to have humans involved in every fault resolution.
Very true. Very true. Very true.
No, and it also highlights, I think, why something you mentioned about webhooks out into ticketing systems and things. It'll auto resolve once things get done. And if someone's not watching the observability platform, or perhaps someone's just turned on all the observability options and they're getting 4,000 emails a minute, no one's going to see the actual critical thing that was in there. So having these smart alerts that are actionable in ticketing systems or whatever your organization's utilizing for that, but then having the smarts to auto resolve if it's no longer a problem, or deprioritize it so that someone can go, well, why did that happen at 3 p.m. today? Sure, it's fixed now, but it shouldn't have done that thing, and loop back to that. So I think that's key, having those integrations in, be it a push out of the system through a webhook or similar, or an API call in to pull that data out and consume it yourself into your own system.
Yep. And those alerts and pieces of information probably need to vary by network zone at the edge. So the edge shouldn't be viewed as just a ubiquitous thing. At a retailer, for example, the edge is protecting the payments network, the back office network, the IoT sensor network, etc. And out of those three examples, each of them are going to have different criteria for needing to be connected, acceptable downtime, acceptable missing information, etc. And the alerts need to accommodate the different requirements of the different zones on the edge, I think.
That's actually an excellent point. Maybe to extend on that also, I usually go back to almost a label that location matters. I mean, there's a point to why you're running something in a location, both on the kind of site level, but also inside of, let's say, a retail store. And so things like disaster recovery becomes a little different, because you can't just fail over a point of sale system from Stockholm to Gothenburg in Sweden, right? That makes absolutely no sense. So the whole entirety of what is the meaning carried by these locations, and how do we correlate that into, for example, observability data and behavioral patterns that we can then do something about is another thing that, again, if you're looking at this from a background with the cloud, where that industry in a very interesting way has done everything they can to almost erase, as they should, the concept of a location, maybe for disaster recovery or for that kind of failover scenarios. Otherwise, location should be, it's out of sight and out of mind. While here, of course, again, in the edge, location is usually the point. It carries meaning, which again impacts most of the things that we're talking about here.
And that has a lot to do with how edge is different from data center. So most of what we've been talking about, I would categorize as being far edge. So it's a place that belongs to me, but has no data center. And so this is a sort of place where there's no reliable power. There's no reliable temperature control.
There are no armed guards.
No armed
guards outside.
One of the places I've worked as a fertilizer manufacturer, so there will be dust-blown fertilizer running through these things, and that's both corrosive and also abrasive. So the characteristics of the actual physical hardware you put in need to be different for that. Something with a fan is not going to be happy.
Interesting.
Well, and this brings actually another interesting point too, and something that I sensed in presentations from both of these companies and also all of our discussions. Is it fair to say that Edge has a different end user, a different persona? You were talking during the Avassa presentation about the personas, and one of the things you emphasized was that the application owner not just doesn't care about infrastructure, not just shouldn't care about infrastructure, but has a completely different mindset. And it seems as well, hearing about the kind of customers that are using Mako at 10,000 gas stations or restaurants or whatever, it's a very different user. I hate that word, but it's a very different user for IT systems. Am I wrong?
I think user is the right term. They use them. They don't necessarily understand them. I think it's incumbent upon technology vendors to deliver technology in a way that can be used, because ultimately those users are the people that are leveraging that technology for their and their business's own benefit. But we need to understand that they can't be their own troubleshooter typically. And so those users of devices or applications on the edge are going to call someone for help. And so those platforms need to be able to physically shift where that assistance comes from, because it's typically over the telephone or over a chat mechanism, not someone turning up to the site to fix a problem.
Yeah, I think maybe it's a recalibration, rather a radically different kind of user, but certainly has less capacity to care for the infrastructure in a very distributed network, of course. Again, if you run single cluster but very large applications, it might be in your best interest to actually understand the clustering stack, but it's going to be a tough call to ask someone who's the application owner to actually understand the entirety of that distributed infrastructure and all the moving parts to it. I think that is probably a non-starter for most application teams.
I've been drawing a line to the DevOps methodologies, and I've just realized there is a big glaring gap in that, because the way most DevOps teams work is that there's one team who are responsible for deploying the infrastructure and for building the application on top of that. And you simply can't do that with the edge. You've got to have that segregation of duties. You don't have a set of shared services from which you can build your application at every edge location. You have to build your application to sit inside the limited capabilities and functionality that's available there. So the DevOps methodologies where you bring those things together just don't work at the edge because there isn't that uniform service.
I'm making the same observation, and that's also actually a side effect of the fact that that mostly for the type of on-site or far edges that we're talking about here, the amount of compute you have is limited. And it also, we've seen a couple of times, application teams and actually some of the operational teams that have never met the out-of-management daemon before, or the out-of-management process manager in Linux, that then literally randomly starts killing off processes, right?
And that could well be containers that are just being randomly killed off because your host is...
So when you start hitting the hard borders, in scaled-down environments, all kinds of random stuff happens. And it's almost like we're going back in time. And I know you like going back in time, Stephen. You're that kind of guy.
I'm time traveler.
And time traveler. So actually starting to think about resource consumption and starting to think about the hard borders of a NUC cluster and get away out of the mindset that we just pay our way out of that with cloud services.
Well, that's exactly right. I mean, I think we've got lazy in a way because the cloud has unlimited resource and application developers can
well done, cloud.
13 of those, and that's all good, and someone pays the bill or tries to decipher the bill at least at the end, and then eventually pays it. And that's exactly right. And developers, maybe not the infrastructure people so much, but the developers of these applications that are getting deployed to the edge need to understand those limits. And then I think the infrastructure side of that, those teams need to be able to set those guardrails so that things can't get too out of control. Set them that they can only deploy up to that many gigs of memory or CPU, or utilize that much network bandwidth, or whatever it might be. I think that's absolutely critical part of what we're talking about here around, especially automating things out.
It's a different calculation too, because if you need to scale, if you've got 10,000 locations and you need to scale up the RAM, doing that times 10,000 is very different from doing it once in a data center. So there's advantages and disadvantages to doing things at the edge, and they've got to be balanced.
Yeah, and we've had the conversation a couple of times where we've seen some of our users do what we now call edge shifting, because I like labels. Right? They move containers from centralized clouds to the edge. And at times we've met them and they've showed us the container and it's 4 gig. It's 4 gigabyte size, which means that it's bigger than a traditional VM. And so we've had to kind of carefully turn them around and say, please do a little better, because that will blow your entire resource budget out of the water with your first computer program. And let's see if we can shave some of that maybe down into the hundreds of megs, depending on what kind of solution you have. So maybe that's another edge native criteria, is to not be a resource hog.
Well, yeah, resource constraints.
Yes.
And I think that's loud and clear from all of the companies we're talking to. And it's not just, I think this is important, it's not just the cost of devices or the power budget or the size, the physical size. It's all of these things. It's the number of ports. It's the shipping, it's the everything that goes into these devices, because at scale, as you're saying, at scale, things get very expensive very quickly. And there's only, and that's another thing I think that's interesting too, is that there's only certain steps that you can take. So, right, you can have a 5-port switch or an 8-port switch, but you can't have a 7-port switch, right? You can't have, 13 gigs of RAM, that's just not going to happen. So you better make it fit in 8.
Yes.
And things like that. And so we have to figure out how to make things fit in a way that, as you point out, we don't have to do in cloud, because in cloud you basically have infinite scale.
Yeah, and it could be just as simple as, I mean, some things won't just be able to be physically, well, virtually smaller because they just can't, but not just lifting and shifting what you've traditionally deployed in the cloud, like having a little bit more thought about it and go, well, does it need to be based off that really heavy image, or could it be based off the more lightweight Linux image or whatever, and just think about how things are packaged. So not just deploying the same package everywhere if you are running that same kind of application in the cloud, so to speak, and just put a bit more thought into it. And yeah, I mean, people will soon realize when like say, when processes start getting killed off because they've deployed the huge services down there, then they'll soon learn. But yeah, having the forethought before you start rolling out to tens of thousands of sites, I think that's critical.
And the same thing goes for running all the different Kubernetes services if you're not using them.
I did not say that, Steve.
I said
did not say you did say that.
That's another challenge, because I mean, anything that you're running that's using up resources is something that you have to ask: do I need to be running this? Is this really a valuable use of my resources? Yeah.
And another topic on top of that is actually something we've lived through, so to speak, by implementing it, is that doing multi-tenancy on very constrained hardware resources is actually a different ballgame than doing it on hardware boundaries, which is what most multi-tenant solutions for the cloud is. So you actually have to do it on, with let's say an uneven set of tenants, maybe on a three node scale cluster, and that has to be survivable in failover scenarios. It's a vastly different thing than doing it in a sea of compute in some centralized location. Yep. So take some afterthought to do that in a way that actually works in a scale down or pared down environment.
So we've, I think, come to the conclusion, yes, that it is fundamentally different to be running things at scale when the scale that we're talking about is edge scale. And all the different resource constraints and all the different challenges. Final thoughts? What do you think about this challenge of deploying and running applications at global scale? You want to start?
Yeah, I think a combination of edge and cloud is the right choice. Not everything should be on the edge, not everything should be in the cloud. So think about what's appropriate, make sure there's a solid networking foundation or it's going to fall over regardless. But yeah, the edge and the cloud are different and suitable for different purposes. And I think mixing and matching is right for most end users.
I think it's really important to look at how you're doing your automation and make sure that your automation is very much driven by policy and handling exceptions, rather than having to really take the same process and watch for the outcome of every automated action.
And obviously I'll latch on to that first voice here to say that there is definitely a two-layer application topology emerging here. And obviously think about how to manage that as a coherent whole and try to see if you can build an environment that is super comfortable for the application teams. So they will right size and right balance, just like you said, the appropriate applications to the appropriate locations, and actually have them go a little back and forth until they find the right balance here. And that sounds easy, doesn't it? That sounds pretty straightforward.
Yeah, I mean, all really good points. And the only thing I'd really build on is to make sure that security is considered, not only from a deployment perspective and making sure you're doing all the things right in the application layer, but also right down through the network. So I think we can't get complacent with that stuff. And as it was highlighted many times today, Edge has its own security considerations to deal with, or whatever it might be. So I think, yeah, security is one of those things that's front of mind for every organization, regardless of how big or small, or one site or 1,000 or 10,000. So.
Well, I really appreciate you bringing that up, because that's the topic for the next Edge Field Day
that was not planned
discussion. And so keep an eye out for a discussion of automation and security at the Edge, also coming from Edge Field Day. So thank you very much for this wonderful discussion. It's been very illuminating today at Edge Field Day, and also in the discussions we've been having online and going forward. So I appreciate this. Before we go, let us know where we can find you and continue this conversation. Simon?
Easiest place to find me is either at makonetworks.com, LinkedIn, or you can email me, simong@makonetworks.com.
You can find me, Alastair Cooke. If you just Google Alastair Cooke and put something virtualization related in, you'll find me. If you don't put the virtualization in, you'll find some cricketer. You can also follow me on DemitasNZ on Twitter, and do check out Build Day Live, because if I can convince either of these gentlemen that they'd like to actually show the world how their product works in real-time video, then we'll be bringing back Build Day Live and showing you much more of the actual hands-on experience of using tech infrastructure products.
Done. So yeah, the easiest way here as well is, I guess, avassa.io. Email me at calle@avassa.io. That's CALLE, Spanish word for street, just so happens, at avassa.io. I'm at C. Moberg at Twitter. You can also find me at Mastodon. You have to search for me at that place. And I think that's it.
Nice. Ben Young NZ on Twitter, or benyoung.blog. You want to hear me rant on about various topics. Or ben.young@vbridge.co.nz. You want to email me, or LinkedIn.
And as for me, you can find me, Stephen Foskett, at Gestalt IT and various podcasts that we run, as well as the Tech Field Day events. We have 2 weekly podcasts, the On-Premise IT podcast, as well as Utilizing Tech, and a weekly tech news program called the Gestalt IT Rundown, which you can find at Gestalt IT Video. This roundtable discussion was recorded as part of Edge Field Day, and you can find the other 2 companion episodes, Defining the Edge and looking at security and automation at the edge, at the Tech Field Day YouTube channel. You can find more from the Edge Field Day event as well by going to techfieldday.com. Thanks for joining us, and we'll see you next time.